Hi everybody, this is going to be a video on vertex form. Vertex form is one of the three forms of equations that we use for graphing quadratic equations, parabolas. Um, in most people's opinions that I've seen so far, this is their favorite form. This is kind of the form that takes the least amount of calculations, which I know a lot of people are really in favor of. This is a form that's really visual, so you can see a lot of information uh, right in the equation without doing any calculations. So the first thing that you can see is translations and reflections. So translation is just a word in math that means moving up or down or left or right. The shape of the graph isn't going to change. It's just going to move left or right or maybe up or down or maybe both. And then reflection means that we're just going to flip it, sort of like that. So that's a reflection. We can flip things left, right, and we can flip them up and down. Typically with a parabola, we think about flipping them up and down. Flipping a parabola left to right doesn't really do anything, as you can see. It's symmetrical, and we know that. So flipping it left and right won't really do anything. We'll just talk about reflecting it up and down. Another thing that can happen would be you can change the steepness of a graph. So let's say that this is the parabola that I'm working with, and maybe I want to change it a little bit, and I want to change the steepness of it. So one thing you can do is you could make it so that it looks like this instead, really sort of way skinnier. Or you could make it a lot wider. So the combination of making things wider or skinnier, as well as moving them side to side or up and down, and then flipping them over perhaps, that's going to create any parabola that you can possibly think of, just those two things. We need to figure out how do we get those things to happen. So I went ahead and I graphed these ahead of time, but the one thing that I didn't graph ahead of time was y equals x squared. Y equals x squared is what we call the parent function for parabolas. It's kind of the parent function because it's like the mama of all the other parabolas. All the other parabolas are just kind of a screwed up version of y equals x squared. So we'll start with y equals x squared. If x is 0, then y is 0. If x is 1, then y is 1. If x is negative 1, then y is 1. If x is 2, then y is 4. Sorry, that's 4. If x is negative 2, then y is 4. So it's kind of got that shape going to it. You can also do one more point. If x is 3, 3 squared is 9. If x is negative 3 squared is also 9. So we kind of get that shape. I'm just going to leave the dots on there for now because when I draw the line in, I do a terrible job of it. So let's look at the graph of y equals x squared plus 1. So if you look at the sort of granddaddy graph y equals x squared, you can see that y equals x squared plus 1 looks almost exactly the same, except every point is moved up 1. So 0, 0, that used to be right here, it moved up here. 1, 0, which used to be right here, or sorry, 1, 1, which used to be right there, got moved up to 1, 2. 2, 4, which used to be right there, got moved up to 2, 5. Everything just got moved up 1. So we can remember that pattern. When we add 1 or add 3 or take away 3 after the x is squared, then that's going to move it up or down. Kind of something similar, but more interesting, happens with when you put x and then add a number to it or take away a number to it inside a parentheses and then square it. That's going to do something different. As you can see, the difference between this x plus 1 squared and the x squared is everything shifted left 1. So we used to have a point here, our vertex at 0, 0. Now it's over 1 to the left. We used to have a point right here. Now it's 1 to the left. We used to have a point right here. Now it's 1 to the left. Same thing. So this adding 1 inside the parentheses actually makes it go left 1, which I know probably seems backwards to a lot of people. Last thing is negative x squared. Putting a negative in front of stuff is going to make it be upside down. It's going to have the exact same shape. It's just going to be upside down. So using those 3 pieces of information, we can graph a lot of different things with hardly any work at all. So let's just try to graph this first one. What I always do is I write in words what are the different transformations that are happening. So I'm going to write here, this negative in front of everything means it's going to flip. It's going to flip upside down. This plus 3 here means it's going to move left 3. And this plus 2 at the end means it's going to go up 2. So these are the transformations that are going to take place on y equals x squared. We're going to take this graph right here and we're going to do these things to it. We're going to make it go left 3, we're going to make it go up 2, and then we're going to flip it over. So we'll just start with that. Our original vertex was at 0, 0. Now we're going to take it, we're going to move it left 3, we're going to move it up 2, and we're going to put a point there. Now our next point would normally go right 1, up 1, but this graph is going to be upside down. So we're going to go right 1, down 1. Then we're going to go left 1, down 1. Then we're going to start back at the vertex. We're going to go right 2, down 4. We're going to go back to the vertex. We're going to go left 2, down 4. That's all the points you need, but you can add some more. You can go back to the vertex. You can go right 3, down 9. I think that's going to bring us down here to negative 7. And then we can go left 3 from the vertex, also down 9 again, because 3 squared is 9. And we get this nice shape right here. So it's got the same shape as y equals x squared. It's just slid to the left, it's moved up 2, and then it's flipped over. Something similar here. So let's see here. This minus 4 is going to make it go right 4. Since it's in the parentheses, it's going to be kind of backwards of what you think. So it's going to go right 4. And outside the parentheses it says minus 3, so it's going to make it go down 3. And there's no flip going on here, so we're just going to go right 4. We're going to go down 3. There's our vertex. And then we're just going to follow our pattern. We know that a normal parabola goes right 1, up 1, left 1, up 1. We know that a normal parabola from the vertex goes right 2, up 4. So we're going to do that. And back to the vertex, it goes left 2, up 4. We could put more points if we want, but we really only need those 5. Then our graph looks something like that. So I got the exact same shape as y equals x squared. We just shifted it left and right. All right, moving on to the second part. There's one other thing that we talked about. That's changing the steepness of a graph. The steepness is represented by a number that might be in front of those parentheses. We call that value the a. It's the same a that you see when you write a parabola in standard form. It's that same a. It does the exact same thing. So that a lot of times I refer to it as the steepness of the graph. I kind of call it the steepness. I'll show you what I mean. So now we kind of have a graph, an equation here that's kind of similar to before. There's some transformations taking place. I'm going to go ahead and write down these ones that I already know. So this minus 3 in the parentheses, that's going to make it go right 3. this minus 7 on the outside is going to make it go down 7. So our vertex is going to be, instead of being at 0, 0, it's going to go right 3, down 7. So our vertex is actually at 3, negative 7. That's why they call this vertex form, because we can see what the vertex is. It's our y is negative 7, goes there, and our x is positive 3. It's kind of the opposite of what the x is. So a lot of people say, to remember this, they always just say x is a liar. So y is telling the truth, it's minus 7, but x is a liar. It's telling you the wrong thing. All right, so we know where our vertex is. Now this graph is going to be twice as steep as a regular graph. So what usually happens? Well, I'll graph what usually happens in black. So our vertex would be right there. Then what normally happens is we know it goes right 1, up 1. Then we normally know that it goes left 1, up 1. But this graph is going to be twice as steep. So I'll show you how we can figure that out. This graph is going to go right 1, up 2, twice as much as 1. This graph is going to go left 1, up 2, twice as much as 1. I'll go back to the black real quick. The normal graph, the y equals x squared, just goes right 2, up 4. So it normally went there. Left 2, up 4. It normally went there. But this graph is going to be, again, twice as steep. So instead of going right 2, up 4, it's going to go right 2, up 8. All the way up here to 1. Left 2, up 8. So now we can see our parabola there in, holy cow. Well, if I could draw a straight line, you would be able to see our parabola, but it's a lot steeper than the parabola of our sort of regular parabola. It's a lot steeper than it. Let's try one more. All right, so I always start off by writing what's happening. So we're going left 3, we're going right, up 2, so left 3, up 2. So let's just get that vertex on there. Left 3, up 2. Our vertex is at negative 3, 2. And then if there wasn't an a value here, if there wasn't a 1/2, I would just start putting in the rest of the points. But now we got to think about it a little bit. This graph is going to be half as steep as a regular graph. So what normally happens? Let's start here at our vertex. We normally go right 1, up 1. But instead of that, we're going to go right 1, up only a half. Normally we go left 1, up 1. But now we're not going to go up that much. We're going to go left 1, up a half. This graph is going to be kind of squished. Normally we go right 2, up 4. But now we're not going to go up that much. We're going to go right 2, up only half of 4. We're only going to go up 2. It's going to look like that. Now we're going to go left 2, not up 4. We're only going to go up half of 4. So we're only going to go up 2. We can try this one more time. We normally go right 3, up 9. But now we're only going up half as fast. We're going to go right 3, up 4.5. So I think that's going to bring us up to 6.5. Same thing over here. Left 3, up 4.5. And then we get sort of a parabola that looks like that. It's quite a bit wider. It's kind of more open. That's because our a value here is making it less steep. In the previous problem, our a value was a full 2. It made it more steep. So with those pieces of information, we can graph any parabola whatsoever. just one more thing to keep in mind is that if there's a negative in front of here, it would just be upside down. It would still be half as steep, it would just be upside down. So it would kind of have this kind of shape to it if there was a negative there. But the negatives work the same way that they've always worked. I have one example. If you guys want to try this one yourselves and show it to me, this would be a really good problem to come and show me or Mr. Peterson. If you have questions on anything, this would be a problem that we might want to go over with you just to make sure that we know what's going on with these different values. All right, thanks for watching. Have a good day.